Welcome all to our office at Utrecht from DEA. I wish you all very welcome here. Today we have two talks at our meetup. The first one is by Wessel Loth. He's going to talk about web components and how to work with the framework Loth. And the second one is of Pim Elshoff about testing absolute units. So without further ado, give a warm welcome applause for Wessel.
Good evening, everybody. Thanks for the folks at DEA for hosting this meetup. Really pleased to speak IRL again, against some actual faces here. Well, let me first introduce myself. My name is Wessel. I live in the beautiful city of Zwolle, which currently does not look like this, but it's more like a winter wonderland. Surprisingly, here in Utrecht, it's all, well, not sunny, but it's all very normal, but I had to drive through a blizzard to get here. Nonetheless, happy to be here. In Zwolle, I live with two blondes. One is my girlfriend here at a concert of our favorite band, Muse, and the other one is my dog, who is very photogenic. I'm a lover of cars. I love cooking and then making fancy photos of them. You can usually find me in the boulder gym twice a week. What keeps me busy right now is that I play a lot of Elden Ring. I also play a lot of guitar, anywhere between classic rock and heavy metal. So yeah, that's me in short. I am a lead developer at Arcadie. Trainer, speaker, scrum master, you name it. I love talking at events like this, meetups, offline, online, doing college sessions for the HBO programs here in the Netherlands. That's also something I love to do. And I'm always endlessly curious about technology, so I spend way too much time on Hacker News. Just a quick plug about Arcadie. Who are we? We are a consultancy company in Zwolle. We help companies with their digital questions using mainly the Microsoft stack on the back end, so all .NET, Azure, and on the front end we're full stack, so any framework or no framework, like web components, you name it. Then just a bit about my credentials. I first met web components at ING. Worked there between 2017 and 2021. I worked for the ING investments department. I was the lead platform engineer, which means I was responsible for the quality of the platform, making sure it's as future-proof as possible, and making sure multiple countries work on the same code base in a coordinated manner. But when I joined, I didn't know anything about web components. I had to Google it. Back then, they were using Polymer. You might have heard of it. But they were also not under the impression that anyone coming in for a job would know anything about web components because they were that unpopular back then. So that's where I got my first touch with web components, as well as this application. If you're an ING customer, you might know ING Bankieren, which is the banking environment. Well, I worked on ING Beleggen, which is where you can invest in stuff. And it's a single-page application, so you can do stuff with your money. You can view stocks, buy, sell them, view nice graphs, view information about the markets, all that stuff. So I would say a pretty complex front-end application. But before we dive into that, let's talk about front-end development in 2022. Namely, if you're a front-end developer, you're most likely using one of these three frameworks. Everybody knows them, they don't need no introduction. If you're a bit more exotic, you're most likely using vanilla JavaScript, which is probably jQuery. And if you're not using jQuery, you're using any of these, and I updated these last year, but I think half of them are already out of date, and there's a new batch coming in. So yeah, that's a lot of technologies. But what do they all have in common? Well, namely, it's about working with reusable components, reusable views, making something once, using it in 10 different places. They're all about enhancing HTML, using JavaScript. Just make it that bit smarter, make it just a bit more functional and nicer to work with than just using plain JavaScript. They all have some sort of DOM engine or a virtual DOM engine to efficiently render updates to the page. And they use, almost all of them use some sort of view or style encapsulation, which means that if you're styling an H1 in some place in the application, it's not going to affect every H1 in the entire website. So these are the characteristics of modern front-end frameworks. But maybe we just need web components, because, of course, I'm here to tell you why web components are the next big thing. And that's because they can do anything on the previously listed slide. But what are web components? Well, basically, web components is not an official term. It's kind of a collective term for 3 browser standards. The first is custom elements, then you have HTML templates. The shadow DOM is the third and most cool sounding one. And that's really it. Those 3 combined means you can make web components. So let's zoom into each one of those 3 elements and take a look what they are. So first of all, it's custom elements. Custom elements are a low-level API. And basically anything you put in the template tag, it's in the page, it's parsed by the browser to make sure it's valid HTML and CSS, but it does not do anything. It's just there, it's ready to be used, but by itself it doesn't do anything. The cool thing using HTML templates is that because it's parsed, you can very efficiently create duplicates. The browser already parsed it, the browser already knows this is valid, so the only thing you need to do is get it from the page somewhere and clone a node that's listed over here. And when you do that, when you clone a HTML template, the browser can basically instantly spin up a new template. You don't need to construct new elements. The browser already knows which elements are in a template and can nearly instantly be added to the page. And then the third concept of web components is the shadow DOM. Basically, to summarize, it's a DOM tree separate from the main DOM. So of course, you know your document object model. It starts with the HTML tag, then there's a head, there's a body. In the body, there's your navigation, your headers, your divs, everything. And this is all called the light DOM for those who work with shadow DOM. But the shadow DOM is next to the light DOM. The way you can instantiate shadow DOM is basically on any page or any node in the DOM tree, you can say, hey, this node needs to have a shadow DOM attached to it. And what it offers is true encapsulation, because it's totally separated from the main document object model. There's no such thing as styles leaking out, events leaking out between these things. It might sound a bit like iframes, but it's basically like iframes, but better without having to reference other websites. And the goal is really to protect your elements from those unintended side effects. So what it looks like is basically this. You have your main light document tree. At some point, you have a node. It can be any element on the page. And you say to that node, hey, I want to start a shadow DOM on this place. And in that shadow DOM, you can start building a different model with all your divs and your anchor tags and your elements and your styling. And finally, the browser interprets it basically as one page. It merges this together, but it makes sure that anything that happens here does not interact with anything happening over here. The cool thing about Shadow DOM is you already use it. You probably don't know, but you can enable a setting in your Chrome DevTools or your any DevTools to show user agents Shadow DOM. And what that shows is that most of the default elements have some sort of Shadow DOM implementation. So if you're looking at this input type is range, you might wonder, how does it render under the hood? What does it consist of? And you see that if you expand the shadow root of this element, you'll see a couple of divs, some classes, an identifier, the thumb, that you slide to the left and right. It's all defined there. It's just abstracted away from you as a developer because you don't need to know anything about it. So those are the three standards that build up web components. But those are pretty separate from each other, and that's where web component libraries come in. These are some of the most well-known names in the web component library space. There's, of course, Lit, which I'm here to talk to you about today. There's also Stencil.js, which is a very big and well-known library. Some of the Angular developers might not know, but there's also Angular Elements, which puts Angular in a sort of mode to compile a web component out of your Angular element, ditching the Angular framework entirely. And there's also Solid and FastUI, which is one created by Microsoft. So if you use FastUI, you basically make your application look like Word or Excel. But why would you use a library? Is it a bit counterintuitive? You want to get rid of frameworks, but then you start introducing a new dependency, which is a library. Well, it's all about making the developer experience a bit nicer. As I just showed you, it's a lot of boilerplate code to make a very basic thing work. If you want to listen to a button click, you have to register those event handlers, unregistered at the end of the life cycle. It's a lot of work. And these libraries define some sort of sugar syntax layer on top to make it just that bit nicer to work with. It also offers more framework-like features because, of course, I'm here to tell you today that the web platform as a whole is very mature and you can start relying on it natively, but it's not moving as fast as a framework would because it has to go through the whole W3C committee stage of approvals. Everybody has to pitch in what they like and don't like about the feature before it ever becomes a browser standard. And even when it becomes a browser standard, it can take up to a year, 2 years for a browser vendor to actually implement the feature. So these libraries kind of fill the spot. If you like using decorators, you can do that using a library which has decorators and offers a compile step to make it plain JavaScript again. So that's why you would use a library. And the next question is, of course, which library do I use? Well, I'm here to tell you you should use Lit, but of course that's a very plain and not very objective answer. So I plotted it here in this graph, going from less opinionated to more opinionated. I would place Lit over here. It's very close to browser standards, and also it's quite popular. There's a comparable between the different web libraries using web components. It's a more well-known one. It has a bigger community surrounding it. Then where would you place the next big one, Stencil? That's on the different side of the spectrum. It's very opinionated. It kind of looks a lot like Angular. It introduces some custom concepts for working with web components. It abstracts a lot of web standards away from you, so you don't have to worry about it. And if that's your thing, that's great. Stencil is a great choice. Then there's the other ones, FastUI. It's pretty opinionated, maybe not as much as Stencil, but it's also not really as popular, not as many people know about it. Solid, not really a strong opinion on the way you work with it, but it's also not very well known. And then lastly, we have Angular Elements, which of course is just Angular. It just compiles to web components. But Angular itself is a highly opinionated framework, and it looks nothing like vanilla web components. So that's about the libraries. But now let's specifically talk about Lit. I have a very big quote for you. You don't have to read every word. Really, the last part is the most important one. Every lit feature is carefully designed with web platform evolution in mind, which means that every new proposal, every new handy feature that somebody would like to see in lit, it's always first checked against web standards. It's discussed with people working on those web standards that, hey, we want to do this thing in lit. Do you foresee this becoming a web standard in the future? Because we don't want to deviate too much, and we don't want to make a very opinionated framework. So that's really the essence of how lit is developed. So what's lit in a nutshell? It's a very small library. It's basically one main thing and a bunch of stuff surrounding it. It's a subclass of HTML element. You saw it earlier. If you want to create a custom element, you inherit HTML element. A lit is no different. It's just a subclass adding new features. Of course, it adds a lot of sugar syntax. It also has some great integrated tooling to work with both TypeScript features and just JavaScript. You don't have to use TypeScript if you don't want to, but there are some extra features like decorators and extra type hinting throughout the whole library. The cool thing about the JavaScript version is that you don't need any build tooling at all. You just you link to the lit.js script, and that's it. You can use lit in a browser without any compile steps. It also has seamless interoperability with other web libraries or frameworks even. So if you want to combine any of those libraries I just showed you, you can do it using lit. It's just a web component. It follows the web standards. It can interact with any other web component on the page. It's also less than 5 kilobytes. I saw a date picker library this week, which was 499 kilobytes. I was just surprised that a date picker could be that big, while a powerhouse like lit could be that small. And finally, it renders HTML using lit HTML. Now, lit HTML used to be a separate thing from lit, but lit HTML is really what makes the lit experience very magical. And to demonstrate that, I have a small animation of how elements get updated on a page. So on the left here, I have an example of Preact. For those who don't know it, it's basically React, but a more optimized, a smaller version of it, aimed at being very efficient. And you see that when you're updating just a number over here, both the entire string gets updated and the entire h1 tag, which is maybe a bit too much. And the same goes for those other examples. Now the lit rendering engine, if you can even call it an engine, it's a very small utility. It takes a bit of a different approach. It uses things called template literals and these DOM markers. And by using those technologies, it's able to very localizedly update those things you just want to update. Of course, this is not a very exciting example, but you can imagine that if you're building, like in the case of a bank, a stock page with 10,000 stocks on it, updating in real time, that you do care a lot about performance. And that's where the big wins come in when you're using lit, or lit HTML specifically. So let's take a look at a basic component, a hello world. I have a class over here, a web component, and the first thing you see is that it's inheriting, instead of custom or HTML element, it's inheriting from lit element. Of course, you do need to import it first, but then it's just a web component as you're used to it. You can define styles within the component. You can see it's using a specific tag, the CSS tag, literal, and in there you plot your string of CSS. There's also a properties object where you can define properties that come in or go out of this object or this custom element. Then, of course, there's your lifecycle method, the constructor in this case. You can set some property defaults or whatever. And finally, there's the render function, which returns HTML. So this might be a bit familiar for those using React, but the old style, where you were using class-based React, you would also have a render function, and it would return JSX, which in the end gets compiled to JavaScript rendering HTML. But here, there's not really that much magic going on, because actually this part of the HTML is just a string. But the thing that makes it magical is the HTML template literal tag over here. Now, I won't go into too many details on why template literals cause the very optimized performance I just showed you. But just know that it's just a string, and using this tag in the front of it makes it all, or ties it all together, the updating of values in the HTML. So that's our component. Finally, of course, it's a custom element. We need to register it on the page before we can use it. So that's what the custom element define function at the end does. Now, if you want to use this in your page, it's basically, well, very simple. I need to link my JavaScript file. Be sure to use type module because you're importing a component from a module which is importing lit. And if you're importing other components, it's using the JavaScript module system. And for that to be supported in the browser, you need to set type is module. And then in the body, you can use your tag, which you just defined over here, which renders a beautiful hello world. The cool thing about this example is that you can just put this in your browser, or you can put this in your editor. Of course, you need to install the lit package somewhere in your system, but then you just open index.html and it works. There's no compile time stuff happening. There's no magic happening. This whole rendering the template to HTML, it's all supported without any build steps. So it's basically going back to basics, back to the old days where you could just open an HTML file and it would just work. But still, if you're looking at this, you might think, that's not the most beautiful syntax. There are other frameworks which have done this in a more easy way. And that's true, and that's where the TypeScript version of lit comes in. So the lit TypeScript functions, they provide stuff like decorators here, so you don't need to use this custom element definition at the end. For those properties, you can easily use one single decorator to avoid having to use this entire static get properties function. And there's some other stuff that lit TypeScript provides to you out of the box. The cool thing about this is that, yes, it's TypeScript, so there is a build step necessary, but like I said, or like the quote just showed you, the entirety of the lit library is developed with web platform evolution in mind. And what this means in this example is that those decorators, there's actually a proposal going on to support decorators inside of the browser without any build steps. So eventually, even TypeScript might not be necessary anymore to use this example here on the right. So that's a very basic example of a lit component. Now let's take a look at the component lifecycle, because of course every component needs, or every component system needs some sort of lifecycle for you to do stuff. There's the connected callback here on top. That's basically the web component way of saying, hey, when this component is added in the page, execute some logic. So here you would execute your API calls, fetch some data, read something from local storage. Of course, there's also disconnected callback, so when the component is ripped out of the page, you might want to clean up some connections, remove some stuff from memory. That's where you can use disconnected callback. There's, of course, an update function, so when any of the properties change of the component, you might also want to refetch some data or execute some logic. For that, you can use the update lifecycle hook. And finally, there's the render function, which is called after every property change on the component. There's also some others. You probably won't need them if you're just building basic components, but it's good to know that if you want to do stuff very closely tied to performance and before rendering, after rendering, there are possibilities to do so. So let's talk data binding, because of course front-end applications need to pass data from one component to another one. And that's where those property decorators from lit come into play. So here I have a very basic component. It's a custom tweet. You can provide a username and some sort of tweet message to this component, and it will render a paragraph of text using this data. If you want to pass in data into this component, it's not really different than you would do for any other HTML element you already know. Namely, you just use the basic property or the basic attribute to pass in your data. It's not really any different from saying input type is text. type is just a property on an element. So this is the same, which is very nice because you can use the syntax if you're, for example, progressively enhancing your MVC or server-generated application. Just sprinkle in one tag, pass in the properties, and you're all set. And the result is a beautiful text with some formatting. Now, if you want to work with data streams in your application, you're going to, of course, need to be able to listen to events and send events to other elements on the page. For that, Lit does have a special syntax. It's the I don't know the English term for it, the @ sign here on the button, where you just register an event name and register next to it the function that needs to be called when the event is executed. So here I have just a button. If you click on it, some function gets called. That's not really a very exciting example. So this works for all basic built-in browser events. Usually the syntax is on click, on blur, but here it's just @click or @blur to execute some logic. But it gets exciting when you're, of course, using custom events. So here I have the same tweet example as before, but I've extended it a little bit to have a retweet button. So there's still the same property definitions. You have a username, you have a tweet, you have the render function, but now it also renders a button with a click handler that if you want to retweet stuff, you can do some, execute some logic. Now here on the bottom, I have the function to execute a custom event. And what a custom event is basically just that. It's just an event with some extra, a custom name, some extra details, because of course you might want to send an identifier to a parent component. You might want to send an entire object with data to another component. And for that, you can use the custom event details. There's a lot of other stuff that custom events can do. For example, you can configure the event bubbling. Does it go up the DOM tree? Does it go down? Should it cross shadow DOM boundaries? Because of course shadow DOM is separated from the main page. You might want to keep the event localized to that part of the shadow DOM. There's a whole lot of options there. And the cool thing about events is that it's all native. Lit being very close to platform standards, it just works the way you would using regular events. So if you're using event listeners, if you're listening to click events, it's basically the same system that's in play here. So there's no custom framework eventing pipelines that are very complicated and deviated from web standards. It's just a browser event that you can use outside of the context of web components as well. So when you've created your event, you of course want to send it somewhere, and for that you can call the dispatch event function that's tied to a web component. Now, of course, if you want to listen to that event in another example, you can use the same syntax, @retweet, and then call some sort of function. So let's talk styling. I showed you a very small example before. This is a bit more of a detailed example. So styles in Lit, you have to register them on the component itself, but that doesn't mean that the style itself, the style sheet, has to be inside of the component. You can just import it from some other place. You can use variables, both CSS variables, which is a new technique where you can pass variables through CSS classes, but you can also just use JavaScript variables, because this is just JavaScript, it's just a string. You can import some sort of color or type or font definition, and you can interpolate it inside of that string to render it over here. But yeah, here there's some cool CSS going on, namely the host selector. Host basically means that we're not going to style the children of this component, but we're going to style the component tag itself. Because of course, if you want to use this component on a page, you would create a HTML tag, and it's called fancy component in this example. So if you want to style that exact component, you can use the host selector to, for example, give it a display block or some default padding or colors or whatever. And you can also use the slotted selector to style anything that's passed into this component. So I showed you earlier that you can pass in properties to this component, which is basically just a JavaScript property on a class. But in this example, I am using the slot HTML element, which basically says that if you are passing HTML to this component inside of the DOM itself, we want to place it right here in the correct spot. And I can also style those. So I can pass in HTML from outside of my component into a component and then style whatever's being passed in. It kind of looks like this. So in this example, I have a fancy component with an H3 where I define the slot where it needs to be placed in the component. And then also there's the content, and it can be basically anything. And that's the cool thing. You can imagine this being some sort of news component on your page. The news can be anything. It can be just a headline. It can be a headline with a lot of text. It can be just an image. But using the slotted selector here, we can make sure that whatever is passed in gets some sort of standard styling, so it doesn't deviate too much. So that's basically a short introduction on styling, and the result is a beautiful, well-designed, fancy component. So there's obviously a lot more to lit. There's a lot of advanced stuff available for you, which I'm not going to dive into detail today, but you should know that if there's some sort of business logic you want to execute separate from a component, there's a thing called lit controllers. They attach to the lifecycle of a component, and you can offload your business logic there without interacting too much with the view. There's lots of directives available that you can use to efficiently render views. So by default, lit HTML already works pretty efficiently outside of the box. But if you want to do things such as render a list of bullets, but only update the ones that have actually changed without messing with the other ones, you can use certain custom directives to make sure it's rendered as efficiently as possible. Of course, you can use custom elements, but not use the shadow DOM. That's a combination that's available. So you can imagine that you want to have some sort of element on the page where some JavaScript behavior is attached, but we don't want to really mess with the styling of the page. For that, you can just enable light DOM rendering on lit, and then you can still style the HTML that's rendered from the outside of the component. And of course, if you want to use theming, you want to build a design system, you want to give some customizability for how the HTML is styled on the page, there's things called CSS mixins and variables. These aren't even specific to lit, they're just web standards. So you can style all sorts of things in a very convenient way. That basically is lit. It's not really much more than this. It's, like I said, it's just 5 kilobytes, so it needs to cut down somewhere. So if you want to do any of these things, pick it yourself. If you want to use a build system, that's great. You can use Webpack, you can use Rollup, you can use Parcel, whatever, it doesn't matter. If you want to use a system like hooks, there's libraries available where you can work kind of like React hooks, but then outputting a web component. That's also up to you. If you want to focus on internationalization, accessibility, you want to use Redux as a state management solution, that's all possible. Those are just JavaScript libraries. Just install and go. But lit itself is a very basic library. So you might have seen all this and wonder like, okay, web components are cool, lit is cool, it's very close to browser standards, that's all cool, but browser standards can be finicky. We all know how it's like to work, to build some feature and then have to specifically fix something in Safari because Safari is different from the other browsers. Well, the good thing about lit and web components specifically is that they are all natively supported in basically any greenfield modern browser. The exceptions, of course, are on the Microsoft side with the old Edge and the old Internet Explorer, where you might have to use some polyfills to, for example, use Shadow DOM efficiently. And seriously, if you know anybody still using Internet Explorer, please talk with them. They might not be in a good place mentally. So then the next question is, who is using web components? Because of course, if you're deciding on a new technology for your company, you might want to make sure that there is some sort of community backing. You might want to know there are some resources available. If you want to send or have a new hire, you want to get them onboarded efficiently, it's important that there's a community for it. And the good news is that there's quite a few well-known companies that are using web components or lit or stencil or any of the other libraries in production already, for quite a couple of years even. One of the funny things that I saw online was that the McDonald's menu boards, they are those interactive menu boards that have some animations, that show some video, they have the prices of the products. Apparently those are built with web components as well. In the Netherlands, there's the Rabobank, ING, those are the most well-known companies using web components. And also the politie, they are building their entire new design system based on web components for their, I think, 400 plus front-end applications. So the design system is universal, framework agnostic, and anybody using Vue or Angular, React, it doesn't matter, you can use those same basic building blocks to build your application. So let's zoom in a bit at ING, where I worked, of course, so I have the most experience talking about that. Let's go back a bit to this application, because on this application, everything you see on the screen is a web component. Most of it is using lit, but there's also places that don't use anything as anything at all, because if you just want to render a button with some text in it, why would you use lit? You can just use a native custom element for it. So all of this is built with web components, and they were already built with web components back in 2016, I think. So I have a nice map over here. It's not some map of COVID infections or anything. These are the countries that ING is active in. It's actually quite a lot of countries. That's just to give you a bit of context about the scale of how they are using web components spread throughout the world. And to give some more context and numbers, globally there's 40 million customers, more than 40 countries. I think it's 48 at this moment. There's many thousands of developers working around the world based on the same code bases and the same technologies. Specifically in the Netherlands, there's about 8.5 million customers, 500,000 or some of those were using the investment application that I was just showing. Yeah, there's a lot of teams building on the web platform. There's more than 80 teams in the Netherlands that are working on web applications, and those can be anything from the investment application, the banking application, but also internal software, call center software, you name it, they've got it. And the complexity really varies. The complexity for a company like ING lies in a couple of aspects. They all need to look and feel the same. That's really important for a customer experience point of view. You don't want to go to one application and work in an entirely different way based on entirely different rules from the other application that you might also want to work in. So that's really important to a bank to make sure they all use the same UX and UI guidelines. Multilingual is very important, especially as the bank is growing. They want to build components that scale to different countries, different continents. They need to support multiple languages. So that's a lot of complexity in your front-end application. Accessibility, it's not just important because there's a lot of users that have these requirements, but also it's becoming a mandatory regulated rule for banks and insurers in Europe to be fully accessible for their online services. So accessibility has a very high priority there. Everything they build needs to be able to be used with any sort of impairment, using a screen reader or in a very zoomed in way of working. And of course the functional complexity also widely different. It can be anything from some sort of CRUD page where you sign up a newsletter to a full-on mortgage calculation with 50 steps with lots of interactive graphs and charts. Making the application function in a nice way. So that's kind of to give you some scope on the complexity in the situation that a bank like ING encounters. So why specifically were they using web components? That's really because the first point is the most important. Previous bets on frameworks have been fruitless. I think the previous iteration before web components were introduced was all applications were based on AngularJS. AngularJS back in the day was of course revolutionary. It was the first, well not really the first, but the first big breakthrough in single page application development. Everybody was using it back then. I think almost every bank in the Netherlands still has some applications running on AngularJS. But the sad thing about AngularJS is that one day Google decided to pull the plug and then deprecate it a couple of years in the future. And that didn't really sit well with management at ING because, of course, 80 plus teams, that's just in the Netherlands, working with this technology for a couple of years, that's a lot of money that's been invested in this web platform. So they didn't really want to make the same mistake again. they really want to build something new that's really based or with a vision based on working towards the long term. So not just 5 years in the future, which is already a very long time in IT land, but really 10, 20 years in the future maybe. And there's nothing that's more long-term than a browser standard, because an example is back in the day you had the marquee element where you could slide from the left to the right some text. I think it's been deprecated for like 20 years, but it still works. It's a browser standard. The browsers have already implemented it, and it's still standing rock solid today. So of course, it's no guarantee for the future, but at least that shows some care to how these browser standards are treated by all the different vendors. Of course, a factor is also performance. We've all heard something about research that if your performance is bad, it really costs real-world money, because users are just going away from your site. They don't want to deal with loading spinners all the time. And what's better for performance in the front end than shipping no JavaScript at all? Okay, no JavaScript is of course a bit of an illusion, but if we could cut down stuff that we don't need, so for example, an entire framework that has lots of functionality, that would make a very big impact on the performance that our customers experience. And finally, reusability. Of course, the components that have been built need to be used in 40+ countries. So not all of those developers in all of those countries are using web components already, but they should benefit from the components as soon as they have been built. So standardized login pages, standardized header bars. You really want to standardize those big things across all your applications. And even if those applications are still using Vue or AngularJS or any framework for that matter, if you want to use those components in all of those places, web components are a really good bet for you. Because they are very interoperable with all sorts of frameworks. And yeah, our experience in a nutshell, a rocky start but a smooth landing. The rocky start was back in 2015, 2016, when the technology was first being introduced. I didn't work at the bank back then, but story goes that they were having some sort of developer conference in ING Australia, and one of the Australian front-end architects mentioned something about web components, very cool, very close to browser standards. They wrote it on a bierveeltje, how do you call it? One of the Dutch architects took it home, they investigated the technology further, and that's how the whole story goes. Back then, custom elements, as I showed you, were already a thing, but also back then people recognized that the developer experience wasn't really up to par with modern frameworks. Angular 2 was already becoming a thing back then, React was just up and coming, and they realized that native custom elements were a bit janky or a lot of boilerplate to achieve basic stuff. So back then they went for Polymer as a choice. You might have heard of it. Polymer is a library just like Lit. It's also built by Google, just like Lit. But it's, well, I won't go to too many details, but it's a very eccentric way of working. You don't work in JavaScript files, you work in HTML files. Those HTML files import different HTML files, and it's totally not recognizable compared to today's standard of front-end development. So the start was a bit rocky because, of course, Polymer was just new. ING was basically the only company outside of Google that was using Polymer. So a fun anecdote I always tell is that when I was having an issue with a Polymer component, I would Google the issue, of course. And there were two types of people responding to the questions on Stack Overflow or GitHub. One would be Google employees, always the same 5 or so that were working on Polymer. And the second group of people were my own colleagues, because they were the only ones actually using Polymer in production. So that's all about the rocky start. But the smooth landing is that if you look at the code base today, and I don't really know the most up-to-date version anymore because I've worked there only through 2021. But if you look today, it will be a very simple and clean code base. There's just lit components. I think it's using Rollup as a build system. There's some sort of design system, npm package, and that's really it. There's no complex dependencies. The overall package JSON registration is very, very small. It's a very simple code base to get into. And that's really well, important as well for new people coming in. Like I said, when I joined, it wasn't expected of me to have any web component experience, but the same counts still for people today. If you're coming in, it's very easy to get started with web components, especially if you're used to something like React. The way of rendering HTML, it might already be familiar to you. It's a very simple and simply built technology to pick up. So those are the reasons and the journey that ING went through with web components. And I know from talking with different people in the industry that the cases are also similar. My own girlfriend works at Rabobank. They are using Stencil as a web component library, and the motivations are basically the same. Like, yeah, we don't know if Angular is going to stick around forever, so at least our core elements will make them all web components. Those will be future-proof. Teams using legacy technology, they can use their own thing but still use our components. And when Angular eventually gets deprecated, we still have a design system that's future-proof. So, wrapping up, some closing thoughts about web components. When should you use them? I'm always very excited to talk about web components, but I also realize there are some trade-offs to be made. But when should you use them? Of course, if you care about future-proofness, if you care about working with those browser standards instead of having a big vendor lock-in dependency, if you care about shipping less code to the customer, if you want to build something to share between different applications, different frameworks, those are all very excellent reasons and big reasons why you should start using web components today. But there are some downsides. It's not a huge technology yet. I think it's been growing steadily over the years to the point where most front-end developers will at least have heard of lit and web components, but there's not a big ecosystem. If you're looking for that 500 kilobyte date picker, you're not going to find it for web components because, yeah, there's nobody who has built such a thing yet. And that's getting better and better, but it's not in a place yet where it's comparable to one of the big frameworks. If you really want to easily be able to find answers to your issues, it's still kind of a problem. It's been getting better and better as more people have been adopting the technology, but still it can feel a bit like jumping down the rabbit hole when you're using web components, because instead of landing on some sort of GitHub issue page, you might land on a Mozilla internal bug tracker for the browser, because it's a bug in the browser itself instead of with a web component library. So those are some eccentric issues you might have to deal with. And the last point is, yeah, defining developers with a lot of experience. In the 3 years I worked at ING, there was only one time we had an applicant come in who already had used some sort of web component library. And all the others, all the 50 or 60 others we spoke through the years, had never even heard of them. So yeah, that's a problem. If you want to look for a web component expert, you're not really going to find them unless they probably worked at ING or Rabobank or the politie at this point. But yeah, on the other hand, lit is very simple. It's you can dive in the code base on GitHub and really start understanding it within a day of reading the code. It's not really that big of a framework to understand, so it's very easy to get started with it. And if you really want to dive deep into the details of very hyper-efficient rendering, you'll get there soon enough. So I want to leave you with one more nice quote, and that's that migrating between frameworks every few years is pretty shit, but you'll never have to worry about it anymore when you're using lit. So I have a couple of resources left for you. So if you're wondering, how do I get started? How do I learn about these web component libraries? There's an excellent tool called webcomponents.dev. You just click any of the libraries listed here and you instantly get an environment where you can start building a web component. It looks like this. It's a bit like a stack blitz. There's some default examples included here, and you can very easily get started with exploring the technology. There's also some other resources, OpenWC, Open Web Components. It's a collective started by some Googlers, some ING employees, and some other companies around the world using web components. And this is really about providing recommendations and tooling to make the developer experience as nice as possible. For example, they have a CLI, so if you're big into CLIs and generating your new application and adding components, there's something for that. And also on the right, you see all the different plugins for different build systems. If you are looking for some guidelines on unit testing, what testing framework do I use? How do I test the shadow DOM? It will all be listed over there. Then there's Lion, I have to mention it. Lion is a white label component framework or component library. Basically, Lion is here on the left. It's very ugly, but it provides you with components with a lot of functionality in them. So of course, a standard date picker has very limited validation options, but if you're looking for a date picker that has lots of options and lots of customizability, you can consider something like Lion. It's basically a set of HTML elements, lit components. You can inherit them, override the styles, and you're good to go. So that's a very cool library. On the right, you can see what ING does with it. Lion is open source. That's basically the bulk of the functionality. And on the right, they just apply their own style sheet, and that's it. They're ready to go. And finally, if you're considering using web components or slowly migrating to it, there's custom elements everywhere. It will show you all the main frameworks that you know and love and show you what the compatibility percentage is. So I think almost every framework has 100% compatibility for integration with web components. The only outlier is React, where there's a few bugs in some specific cases. But I think they're working on it, and that's something you can view over here. So you can view this, or take a photo or a screenshot, or look it back on the stream here if you want some links to different resources. If you're Dutch speaking, I also wrote a 6-part blog post diving much further into the details of web components. But I hope at least that I've given a very basic introduction of the technology to you guys today. So that's it. Thanks for joining.
Thank you very much, Wessel. It's getting a bit dark here, but it was a really enlightening talk, spreading the word about web components and why it's the future and future-proof. Are there any questions?
Yeah, you mentioned that there was not...
Just wait a second.
Yeah, so you mentioned there's not many components ready to use yet, but I know back with Polymer 0.9, there was webcomponents.org, where they had like Iron, Ajax components and all that stuff.
Yeah.
Can you still reuse those same components, or do you need to build them from scratch for lit?
Yeah, that's a good question. You're referring to webcomponents.org. It used to be a very good library and a resource for learning more about web components. Nowadays, it's a bit stale. There are still standard components listed there that you can install and use. For example, Google has a bunch of the Iron components you mentioned. Also, material elements, they're all listed there. I wouldn't recommend them because they're built on Polymer and a bit deprecated in that sense, but in the end, even Polymer components are just web components, and web components follow those basic standards, so you can still use them today, and probably in 10 years you will still be able to use them.
Yeah, thanks.
Any more questions? No? Okay, thank you very much, Wessel. We will be sharing the blog post of Wessel also on our Slack channel, and link there the internet links Wessel just talked about there as well. You can find the Slack link on our meetup page. So yeah, let's have a break. Let's grab some drinks and chat about this interesting talk. And in about 50 minutes, we will join Pim with his talk about absolute testing units. Thanks. Testing absolute units. the second talk. Yeah! Great, great. So we're going to talk about, I'm not going to talk about, Pim is going to talk about testing absolute units. So I'll give the word to him now and give him a warm welcoming applause.
Yeah, thank you so much. It's been a very long time since I've been on stage anywhere, so I'm super nervous. And another speaker called Jeroen van der Gulik once told me, if you're ever nervous when you get on stage, like the trick to managing that is just start with some random story. And then you can relax into the story and then... but of course, if you want to start with a story, like that's also an opportunity for us to connect a little bit. So I have a story, but I don't have a story like for you. I have a story about me. A story that you probably can't relate to at all. Because a couple of years ago, quite a long time ago, I was not a very good developer. So that's something you probably can't relate to at all. So I had like my typical week was like I'd start on the Monday morning and I'd have coffee and I'd get a new ticket and I'd start working on it, and then Tuesday and I had a new cup of coffee and the same ticket and I'm working on it, and then Wednesday and there was another bug and I had to fix that and I had my cup of coffee, and then Thursday and then Friday, and then they asked me, Pim, are you done? And I'd say, I think so. So if you were my mentor, what advice would you give me? Be a professional. Sorry? Ah! That's a noob trap. Yes. How would you deal with being like more of a professional? And I was inspired by another story that I also blatantly stole from someone else. This is a story by a guy called J.B. Rainsberger. He's on Twitter as G-Brains, not to be confused with JetBrains, because that's not a speaker, that's... And his story was about tennis. He started one of his talks, which I'm now also blatantly doing, with a story about tennis. What is the difference in ability between the top 10 tennis players of the world and the top 200 tennis players of the world? Why do the top 10 players in tennis win consistently compared to the top 200? Any idea? Luck, obviously. That's also how I feel when I press Control-Shift-R. Practicing hours. That's a good shot, but it's not it. Because if you go 1 or 2 sets, 3 sets, it's about equal, the top 200. But when you start going to 5 sets, it shifts dramatically. And the answer, apparently, according to some study, is heart rate. The top 10 tennis players in moments of downtime have a consistently lower heart rate, like by 10, 20 BPM. Than the rest of the top 200. Heart rate. So, apparently in tennis, the key to winning consistently is to have a consistently low heart rate. Guess you can't say relax, but yeah. So let's consider heart rate in software dev. What gives you a high heart rate? Bugs. The bunny or the production, what? Really? Oh, I never feel like... Yeah. So a high heart rate, something like uncertainty, like a bug, it's what's happening here. Maybe even something like distrust. You deploy to production, won't it cause an outage? Maybe something like, difficult English word, can't see good. Opaqueness. No idea what's happening here. These things give me a high heart rate. In fact, Just this week, I've been working on a legacy piece of software. I had no idea what was happening. I had a very high heart rate. I didn't monitor it, though. So this is all made up. No, it is. So what will give you a low heart rate? No production outage, sorry. Automation. Very good.
A terminal full of green OKs after you run the tests.
Nice. I like it. And I'll shove those in the same corner. Trust. Oh, you paid attention to the previous slide. Something like, it's not on there. Oh, but it was very good. And of course, trust has to do with this. The ability to be able to trust, exactly. The ability to be able to trust that when you do something, it doesn't blow up in your face. I can relax now. I'm just working. I'm just keeping a consistent pace. I know what's happening. I know. Knowing is the key. I know. I don't have to guess, pray. I know. Knowing is the key. The low heart rate comes from knowing. When we know, we can relax. And so when we work, we go from things that we know to things that we might just know or on the edge of knowing, and then consistently expand our knowledge to make sure that everything is done by the end. And then we've reached Zen. Now, of course, Zen is reached at the end when you're done programming, and even then, sometimes not. Zen, knowing. How did you get to knowing? How did you get to Zen? What had to have happened during your software development in order for that knowing to occur? How did you learn? Learn. Recently, Mr. Woody Zuhl, who is the inventor of mob programming, tweeted this. It's not a part of the job, it is the job. We learn all the time. Of course, a large part of our learning is just being technically adept. But you also need to implement someone else's problem. So you need to learn about their problems and your own problems. A lot of problems. Now we learn. This is from a book called Training from the Back of the Room. You can forget it after this. But we learn by attaching to existing knowledge and then being exposed to new theory, practicing with that theory, and then reflecting on it. So we attach, explore, apply, and reflect. And then we've learned. So what does that look like in a development process? Well, that looks something like, first, we consider what is there to do here? What's left of all of that? How should that system behave? How should components behave, and how should they be implemented internally? So that almost looks like features, and then a feature, and then there's a scenario that we're implementing that's decomposed into certain problems, and that's implemented. Oh, that looks a lot like we go from a conversation to a specification, to an executable specification, to integration tests, to unit tests, to actual working code. I'm not saying this is easy, I'm just, flat theory. But this is from, I had no idea, towards, yeah, I know. This reminds me of an XKCD. Are you familiar with XKCD? You know this one? The cool thing about programming is it is math. You can trick the computer by saying, dude, just trust me. Mostly. But on the other hand, it's also sociology. You're talking to people, you're getting to know, hey, how is this supposed to work? How's that supposed to work? What's the issue here? We programmers have to do both. And we need all the help that we can get to make that happen. So, today, we're not going to talk about natural language specifications. Outside of other presentations are good for this, so we do something like user story. You all have a way to eventually turn this into a Jira ticket and then come up Monday morning with fuel. And so this is not for today. Today we're going to start with executable spec. So, not just another dev, but another human being, someone who's not a dev, should be able to agree with you when you run and get green thingies, that it works. Now, I'm sure maybe many of you have heard of something like Behat. That looks something like this. Who has heard of Behat? Oh, something new for tonight. Cool, it's already a good evening. Can you all see this well? You need to get bigger televisions. So Behat, this kind of looks like a user story. And Behat starts with a user story. It's just in a little bit different order, because you all know user stories as a user, I want a story so that I can fall asleep. This is in reverse order. It starts with what we're actually trying to achieve here, and then move on to the yeah. So apparently, there is some lots of words stuff happening here. There is a feature that we're trying to implement, and that feature has one or more scenarios. Scenarios meaning like an archetypical way in which we can describe what our system should do given these circumstances. Now, these are a lot of hard words. That's because I work in insurance, and in insurance we have a lot of hard words. So let's dive in a little bit. You can forget everything that we're going to talk about. It's just to set up the stage for what we're going to talk about tonight. So, insurance. We talked about a non-scheme midterm adjustment. That means scheme, the company I work for, sells insurance policies as if we are actually an insurance company. So that makes non-scheme selling insurance policies as a broker, as an intermediate. Now, a policy is a contract, to very difficult words, something about people being safe or something. And then a term of a policy means a period of time, and in the instance that we're working with, this is a year. That's good enough for now. And then the midterm adjustment then becomes an adjustment while the term is ongoing. Okay, good. Words, knowing. So that means that at an effective date, the midterm adjustment will take place, and a kind of like new version of the policy will then go. And then, of course, the customer has to pay for that. So there's a premium, and it's not just a premium. There's the term premium for everything, and then there's also like the current and then there's. Let's start over. Okay, so we don't decide the premium. Someone else tells us this is what the premium is going to be for this adjustment to the contract. And it might give us a new current or a new delta. What's a current? That means, let's say you have a full year. This is the price for a full year. So if you change your price for a year, then you have to pay a delta. Okay, are you still with me, kind of? So a delta, that means, okay, so let's say you pay 365 Great British pounds for a one-year policy, and then you change it to 375 pounds. How much do you pay for the change? Well, no, it's not 10 actually, because you've already paid half of 365 too much, because you only pay for the first half of the year, not for the second half of the year. So for the second half of the year, you get like a refund, but then you have to also pay for the new version of the second year. So that's what you paid too little. So that means math, and okay, so it's... Everybody still kind of with me? Okay. So this is important stuff, because if we get this wrong, then people will get angry with us, and we don't want to get people angry with us. Sometimes, most of the times, all of the times. We don't want to get people angry with us, especially when it comes to numbers. I mean, our programming is math, and we want to get the math right. So this is just about the math. So that makes the scenario that we were working with, given a non-scheme policy, yeah, we talked about that, a start date, we have a premium. When we do an adjustment at a certain date in time, we expect a delta premium to come out of that. Now, how do you know this works? Well, you're going to implement this. And the cool thing about Behat is each of these steps will give you an opportunity to transform from this natural language to a little piece of code that can be executed. Now, this translation is still something you have to do. So let's say one of these will become a little bit of code. By default, if you generate it, PHP Storm can generate these for you. If you use Behat on the command line, they can generate it for you as well. This piece of code will get a function, and that function will get a marker so that it will go back to, okay, so it was this step. Now, by default, it will give you this. I suggest you change it to that. It's a little bit more readable. And it will get a pending exception. And all of these will get a pending exception. So when you start with this and you start running it, you get, I forgot something. You actually have, when this is, I can't point at this. When these are generated for you, they have to go to a PHP file. By default, Behat will put everything in one PHP file. So we don't want to do that. So if you want to have multiple of these, you have to tell the Behat YAML file, this is where you can find your contexts. And then you can implement this step, something like this with just, it's regular code. It's just like the setup part of a unit test. And when you have an expectation, you can just use whatever expectation library you were already used to. So something like PHP unit will work. This is using Spazi's event sourcing assertions. It doesn't matter which ones, as long as they throw an exception when it's not okay, it'll be fine. And then when you run it, it will tell you, hey, you still have this one pending. This one still needs to be implemented. So this is like literally a list of to-do. So getting these scenarios together with your product owner or with your stakeholder, with your client, with whoever, that's a challenge, of course. But once you have them, they will be a to-do list for you. They will tell you what you still have to do. And of course, as you start implementing them, they will fail because you haven't actually implemented the feature itself just yet. And at some point, they will pass. And then you can say, I'm done and I can prove it. And I can prove it. And someone else can read that and go, oh yeah. But it's with the push of a button and not like, okay, manual click, and then who knows how many scenarios. Now I can imagine, Behat's a new tool. You don't want to introduce a new tool, so maybe if you want to start testing with this, then you can do this in PHP unit. One of the major advantages of using a tool like Behat is that it removes a lot of fluff. It's just text. Someone else can read this. A non-dev can read this. You could type out a good scenario, show it to your non-technical coworker, and they will tell you, yeah, I can read that. Okay, given this, given that, okay. When that happens, then, yeah, I can see that. And then you can execute the command and they will see, oh yeah, that actually works. Now, in PHP unit, you could do something like this. That would require a lot of hidden functions somewhere at the bottom of the file. You can still do it. It just adds a lot of visual clutter that people will get confused by. Why are all these braces here? What's the semicolon there? Why is all the brackets there? Yeah, people don't even know the difference between braces and brackets, and you're going to expect them to look at this. But still, getting started, this is something that you could do. It will be, I don't actually know if it will be less effective. I'm assuming it will be less effective. But the point of this is, it will give you this high-level confidence. I have my large stuff that I need to work on. How will I know that when it's done? Well, and you can prove it. So just a couple of heuristics, just from very simple ones. Don't make them too detailed. When you make them very detailed, you will lose the shared model with your non-technical friends. If you keep them at a relatively high level, just focus on the scenario of, okay, so people are interacting with their system, what can they expect? Not too technical, because technical, that's other stuff for. We're going to look at some other stuff. If you have questions, by the way, just shout at me. So, has anybody ever been driven mad by tests? TDD is really hard. Unit testing is really hard. TDD is really hard. It can cause a lot of frustration. I asked a lot of people around. I did scientific research beforehand, and I found that this is actually like the 5 most frustrating things when it comes to tests. With an entry on level 5, scope mixed up, like confused, like what am I even trying to test? Mocks, of course, some people hate them, some people love them, some people love to hate them. It's a wonderful subject to have lengthy discussions on. If you write tests with mocks, mind that you will not lose the ability to refactor. Don't lock too many things down that you can't automatically change, but of course you will know that. Setup. Setup is always also very hard. Do you use randomized data or not? Do you use database connections or not? There's a lot of stuff that can cause the setup of a test to become unfortunate. And once you're in that place, it will be very annoying for your coworkers to write tests because they have to write a lot of setup. Of course, no test. Yes, of course. And of course, what is a unit? This is a really hard question. What is a unit? I have a very lame answer. So if anybody else has a good answer, what do you think? What is a unit? A function. A function could very well be a unit. That's an example, not a definition, but you get top marks. Could more than one class be a unit?
I think it's like a piece of code that does one specific thing, and that could be multiple classes.
Yeah. And the trick, of course, is what do you mean by specific thing? What is one specific thing? But I do agree with you. And maybe you also agree with me agreeing with you. So, unit. You could say a lot of things about this. I'm not going to make too many words dirty about this. A unit for the practical purpose of TDD is something that can be isolated and decomposed, such that it can be observed from the outside without having to know how it works on the inside. All we want to say is this unit, when I give it this, I expect this in return. I expect this unit to behave given this context. For a CI, it's very good to have bigger units, because all you want is to verify that the system is still behaving as it was before, or at least as it should be. And the larger our units are, the fewer tests we kind of need. We don't want to have a lot of useless tests. But for TDD, sometimes having tests that get us along the way is very useful, and you would want some more tests, and perhaps some smaller units. But we'll dive into that just a little bit. A unit of decomposition, being able to decompose the bigger problem into a smaller problem, to reduce the amount of knowledge that we don't know yet but need to know to solve our problem. Could this be a unit? Can everybody read this? This is a piece of code. It doesn't do that much itself. It uses a lot of other classes to do work for it. I guess you could, from some of the words, infer that it has to do with the story that we were working on. It uses words like calculation. It's probably something to do with what we were working on. Maybe transaction also, something we were working on. But what's interesting here is we have some objects, and they play together, and they do some stuff. And this could be a unit as long as we can isolate it. As long as we can isolate it from systems, files, many other classes, and be sure that we can treat it as a little thing on its own. We can send it messages, and we expect that it gives us something in return that we can have expectations on. So here is a test for it. Apparently this has to be able to adjust. And it expects that if we do these two acts on it, then it will give us these two transactions. A little bit of setup, a little bit of expectation, and we expect that it will do something for us. Arrange, act, assert on the whole of it. Not too much setup. Apparently, in my opinion, very opinion, this is not too big of a unit because this test is quite simple. Now there's a somewhat famous programmer called Sandy Metz. Has anybody perchance heard of Sandy Metz? If you haven't, that's a good name. If you're into object design and if you're into like object-oriented programming, Sandy Metz is a good name to remember. Very, very insightful, has changed my career. She has no clue who I am, but she changed my career. And one thing that she teaches is to highlight what's special, what's different. Also what's the same, but also what's special. So when it comes to designing these tests, we can ask ourselves, what is special about this? So when we look at that class before, well, it didn't really do too much of itself. It was mostly making sure that other classes were working well together. That's like almost the definition of an integration test. But we still could say it's like of a unit. I personally don't care so much about the difference between unit and integration. I understand that for some people but to me it's just not that interesting. What's interesting to me is what's special about this. So this premium calculation class has some responsibilities. There's a reason that it's there, and it makes sure that given a history of transactions, when we act upon it, we get a new history of transactions. That's what that thing is for. That's what's special about this. So every time we have a new expectation for this part of the system, we have to think to ourselves, is it really on the whole? Or is there maybe a way that I can make that expectation on a smaller part? Is there maybe a part of what's happening here that's only serviced by smaller objects such that I can isolate them? Units all the way down. So here is a set of tests that we could have for this class. Something that we would start with. Well, we'll expect that this would be able to do these things for us. But as we start implementing these tests and implementing these features, we'll find that maybe some of these expectations don't need to belong on the whole. They can become on smaller parts. So something like this, the premium calculation only makes sure that the larger interaction is still working. But then for a specific kind of calculation, we will have its own test to make sure that that behaves correctly on its own. So as we are working with this code, we want to have the large tests to start us off with, make sure that we know what's happening, and we will migrate these tests, extract them to their own spaces as we extract behavior to its own spaces. And the cool thing about this, anyone ever ran their tests with test docs? You're probably never going to do, I see someone, good on you. You're probably never going to do this actually, but it's the green checks, so you get also bonus points. But this, again, is, even though maybe your coworkers won't all understand all the components of your system, this is something that people can read. Oh yeah, the premium calculations, I don't know what immutable is, but yes, it should be able to be adjusted multiple times. Yeah, you should be able to do a correction. Yeah, of course, you should be able to adjust to a higher current premium. It's almost living documentation. It's not near your code, it's in your code. Of course, you have to spend the time and effort on making these tests reflect what you know. As you learn, you have to reintegrate what you've learned. So how do you get here? These tests, similar to what the BHAT thing was, all the way down are an executable to-do list. You can execute these tests at any time and they will tell you what to do next. So first, when we're implementing our feature test, they will tell us, well, the whole system isn't implemented yet. Okay, yes, that's too big of a problem for me. So I'll run the test and it will tell me what to do, and it will tell me basically write another test. But then a test that is more narrow, more specific. And then that again will be too big of a problem for me to fix. So basically what it's telling me is write another test, and then I'll write unit tests, maybe a couple of them. Start implementing some things. And as we work with these unit tests, we will find that, hey, at some point we've actually fixed our integration test. And if we do that long enough, we find we've actually implemented our feature tests. Dive underwater, come back up. All the while knowing what to do next. Knowing what to do next. Because the system will basically tell you. Basically, I shouldn't say basically. And of course, when you are doing this, all along the way, you do make it work, make it beautiful, and as needed, make it fast, also known as red-green factor. Yes. The big loop, smaller loop of test-driven development. Easier said than done. So let's look at this one. Of course, you're not going to have a finished test. So this is a little bit cheating on my end, but I have to make sure that everything still fits in the allotted time. So let's say you have a test like this. What does executable to-do list mean? Well, it means you're just going to run this, and it will tell you, hey, an error, you don't have this. Okay, fine, I'll give it to you. Error, this function doesn't exist. Fine, Alt-Enter or Control or Option-Enter on your Mac, fine, do the function. Again, run your test. I'm not kidding, when I do TDD, I run my test every 5 seconds. Not every minute, not every 10 minutes, not every 10 seconds, every couple of seconds. Do something, run. Do something, run. I'm not thinking what to do next. The system is telling me what to do next. It's telling me to implement these functions. Fine, file, just implement them. And then it's going to tell me there's a type error because the function was implemented before the type that was passed into the function. So now I have to go to the class and fix the namespace that it was expecting because it was expecting a namespace from the test. Okay, fine. So this is one trick that you need to know. And as you know it, the next time you'll see it or the next time, then you know what to do. And then again, you're going to run the test. Fix these errors as they go. We left the world of errors. And we entered the world of mixed expectations. No error, but the form of what we're expecting and what we're getting is different. So errors, different form, and as we are implementing that with an empty array, we move from errors to different form to same form. And that means we have like an anchoring point, like a reset point. And all we're doing is just run the test and just do what it's telling us to do. And then we get to a point like this, and then it's, okay, a reset point. Something interesting is happening here. The shape of what we're doing is the same, so now we need to look a level deeper, because the shape of these two are not entirely the same if we look what's in them. We were expecting these two transactions, and we got an empty array. So if we ignore array for a second, we have nothing, we expect two transactions. So we go from this mismatch, and then we have to think, okay, so how can we implement these two objects that we're expecting? So then you have to know something about the problem, know something about the domain. I fortunately do, which means that the first one of these is actually given. There's a contract, you have to pay for it. That's £365. So the first transaction is just going to be £365. That one is almost no thinking. So the first one is easy, but the second one actually needs to be calculated. So we're going to ask that other object to do it for us, because this is a hard problem. So we're going to expect that that one will transact for us. That's, of course, going to give us an error, and we're going to do the same thing. And now we are at the same shape again, two numbers, just the numbers are different. From error to different form, different shape, to same shape but different content. And then we reset, error, shape, content. Error, form, content, doesn't matter. Everybody with me? This approach of just run your tests. I see it all the time. I see people writing a test and writing a piece of code, and then they go, run the tests. You are not good at compiling. The machine is really good at compiling. Just run the tests. Just run the tests. Not every minute, every couple of seconds. Just run them. Stop thinking. And reserve your brain space. Reserve your heart rate. I shouldn't say everything. I'm standing here and reserve your heart rate for the things that matter, for the things that you can't let the machine think about. Because the next one, that's actually pretty hard. How do you get from that number that we just dumped in there that's not true to the actual calculation? What's hard about this? That calculation's pretty hard. I mean, we tried it with the slides and I barely could vocalize what was happening there. So sometimes you will come to a part of the system that is just really hard. There's some theories on how to TDD, those kind of parts, but in the end, it's just going to be a calculation that's going to be difficult. And that's okay too. So here we have a test just for that calculation. Drop all the other fluff, just focus on that calculation. It should be able to adjust to a higher premium. We're expecting one transaction, and that should be able to be implemented. And maybe you don't know how to TDD this. I don't know how to TDD this so well because I know the formula, so I'm just going to type in the formula. Well, it looks like this. This is not readable. Maybe if I spend more time on making it beautiful. But it doesn't matter. Because what's hard is only here. There's no other part of the system that's hard. So the tests helped us to isolate a part of the system that was hard, gave it its own space. Now it's hard there. That's fine. That is okay. Something that we have to know, yeah, it happens. We have to know about the domain, understand, learn about the domain, and make sure that we can implement it correctly. Maybe you have cool ideas on how to make this better. Please let me know afterwards. But for now, this is hard in its own space, and that's fine. The rest of the system was TDD'd nicely together, and then there's a little part that's hard. So, how to approach this? Well, of course, a unit is a component you can test in isolation. So create tests in isolation, and you will create units. Plonk. This one's always tricky. If you find that your tests become unwieldy, your setup becomes questionable, then maybe you are missing a smaller unit. Or maybe there's some refactoring you can do. But try to fight the urge to make test setup automated. Remember, tests are code too. That means that you want to ideally just reduce as much as you can the amount of test code that you have. Make sure that if the unit is large, if it's obvious, fine. If it's less obvious, split it up. Make it smaller. Make it smaller. And keep it fast. We'll get back to this one because the 5 seconds. 5 seconds. That means you need to get feedback in at least 4.7 seconds. And of course the to-do list. This is telling you what to do. Don't think about what to do. It's telling you. Use it. Our job is hard enough as it is. So let the machine do the part that we don't have to do. Let the machine do the part that it's really good at. Highlight what's special. Make sure that the tests highlight. Why did I make this class come into existence? Give it good reasons. And then, of course, if something's hard, make that highlighted as well. Oh, TDD. How do you know you've written good tests? The last part. There's a couple of cool little tricks. Here's a sum function, and here's an expectation for the sum function. Is this good code? Does anybody see something that's wrong about this? Not everything is a trick.
You're just testing one case.
Yes. Is that bad?
What if both integers are already at the int max value?
Very interesting. Keep that in the back of your mind. Good one. I didn't think of that one. Nice. How about this? Is this good code? Because?
What if y is 0?
Exactly. Exactly. What if y is 0? That would need to be dealt with. How about this one? Is this good code? Did you know there's a tool you can run that will help you with this kind of problem? Take a guess. I see someone nodding. Have you ever heard of infection? So infection is a tool that you can run, and it will tell you this. It will tell you there was a mutant, and the mutant escaped. Infection will infect your code base. It will analyze the source, and it will make changes to that source, and it will run your tests. And if your tests fail, then you did good. But if it can make changes, and the tests are still passing, you did not so good. So this found a mutant. What mutant did it found? Well, apparently, it could change this piece of code and still have the tests pass. Now, this is a hard one. Of course, it's a really stupid one by me, because you're never going to write a count with less than 0. But the mutation is very interesting, because it told you it could make this condition be always false and still have the tests pass. You're probably never going to see this in practice, but it will tell you this kind of mutant. It can change something about your code, run your test, and still have the test pass. So we could drop this piece of code and it would still work, because the default case is good enough. Yeah. Infection. Infection is a challenging tool to integrate into an existing code base because it's going to find a lot of mutants. You have no idea how many mutants you wrote today. So what you can do is have a specific test suite for infection where you've isolated a piece of your code base that's actually pretty good. And you can run it with a set of mutators that you are expecting. So for example, we use Psalm. Psalm requires us to cast all over the place, but Psalm is not unit tests. So infection will tell us you have 1 million casts that I could change and still have your tests pass, you naughty boy. That's not useful to us. So we disabled the cast mutation. And you can run infection with only covered. So that means only the files that were actually covered by your tests, not necessarily your entire source, but only the files that were covered by your tests will be considered. These options combined will make infection something at least worth toying with. If you have a test suite, give it a go. You will not believe your eyes. The cool thing about infection, a cool thing about mutation testing in general, this is not my own idea at all. This is by a guy named Marcus Scherp. He's the author of the Ruby mutation testing library. Production code is stuff that our system does. Our tests specify what our system does at least. Does that make sense? So what mutation testing does is say what our code does at most. Because if it could change your code without the tests failing, that means it's untested, so it's unspecified. So combined, these two will tell you what your production code is doing exactly. Infection is not easy per se to start with. Testing isn't easy, but this is super, super powerful stuff. So, infection, it's a mutation testing library. It checks your source and will make mutants such that it will hope to defeat your test suite. It's important for infection that your suite is fast, because for every mutant, it's going to run the suite. So if your suite is slow, I ran this on my MacBook for a small subset, generic PHP unit cases, blimp, and it's done. Infection took 40 seconds. We work with Laravel, so a large part of our code base is covered by specific Laravel test cases. I changed my suite to extend from the Laravel test cases. It went to 5 seconds almost, and an infection also tripled in duration. So be mindful of the performance of your test suite, because it's going to limit your options in how to ensure quality. You, sir, would infection find this flaw? Would infection find your some flaw?
That's how it handles exceptions.
Well, the thing is, infection and unit tests both are never going to input something that you didn't tell them to. So if you forget, they forget. And the hard thing is that every function that takes an int and takes another int and produces a float says something about itself. The property of this function is that for every input it will produce a float. Is that a true property? No, it's not. So there is a principle, a concept called property-based testing, which is much less specific than unit testing, because you're not necessarily testing specific input-output. You're saying, for every int and int that I put in here, I expect a float. Is that true? Well, there's a library called Eris that will help you say, no, it ain't. This is called Eris. It's a property-based testing tool. You can ask it for certain generators, have it generate random input for you, and it will not always be the same input, but it will at least be better than something like Laravel Faker, which will be like really randomized input. This is specifically hunting for those kinds of edge cases. So it will very quickly find division by 0, and it will give you the seed that you can use to reproduce it with, so you can run the tests again exactly as they ran then, So you can just put this in your CI, and it will fail, for example, every 31st of the month, or every 29 February, or whatever weird edge cases that you want to find. I'm still not exactly sure when to use this, because you could use it all over the place. I bet your system receives a lot of ints and a lot of strings that you could declare properties for. But I bet if you ever have a random failure in your test suite, then that piece of code would probably be serviced well by Eris. Again, for Eris, speed is essential because it's going to run several functions or whatever you put into it a lot of times, not necessarily max int to min int times, but so what this does is it just brute forces towards edge cases. It will find that your function will fail at some point, and then it will find where exactly that is and tell you. Very useful tool. And similarly to our infection, also a very useful tool. It's good to have in your kit. And that goes for PHP unit as well, or whatever testing library you use. It's good to have in your kit. Same goes for BAD. Good tools, good tricks. But this is what we were talking about. The low heart rate. That's why we're doing this. We want to have a nice working week. We want to enjoy our cup of coffee and not stress ourselves out. So these tools have to serve that goal. We want to move from things that we know to things that we know just a little bit less about, until at the end of the software project, everything is known. And we've slayed this absolute unit. Now for the math geeks, here's an absolute unit. And for the rest of us, here's an absolute unit. Thank you.
Thank you very much, Pim. That was an amazing talk. Are there any questions?
I think I've covered everything.
Okay, that's very well.
100% coverage.
Great.
Oh.
Let me grab something to thank both speakers. So give me a second. So
for the Monday morning, right?
Yeah. Or
So, it's Monday. There's not enough.
no. So if it doesn't get you through the weekend, we can sort things out and get you something more.
Thank you so much. Oh, thank you.
This one as well for you, and
Thank you so
Wessel,
much.
the same for you. So if you want to come up.
Come up.
Thank you very much.
Oh yeah, of course we have to go for the pictures, right?
Yeah, so there's no one handling the camera right now, but
For the live stream.
We'll wait.
it was a great meetup. It was our first meetup in Utrecht. So we're looking forward to host a lot of more meetups here in Utrecht as well. So I will be sending you all a type form for some feedback. So please be your most critical self. It will help us a lot to improve our meetups and find some interesting new talks where experts can talk about. So for now, let's have a drink and enjoy the rest of the evening. Thank you very much.
Thank you. Applausje voor de organisatie. Hey.
En Joelle.